So welcome everyone to this demo session and to Open Science Fair also. I hope you are enjoying this conference, this virtual conference since 2019 that we were all together in Porto. So just a brief housekeeping notes that you may all have seen this yesterday and from the previous session. So in here, you can make questions in the chat. You can virtually raise your hand to communicate with the speakers or use the chat. This event is being recorded. We ask all of you to keep your microphone muted during the presentations and unmute only if you want to interact with the speakers. Presentations will be available and also the recordings in Zenodo and on YouTube Open Science Fair channel. Please use for social media the hashtag Open Science Fair or tag us Open Science Fair when speaking, when addressing this conference. And also a last remark for the code of conduct that is available on our website and that we kindly ask you to all to read it. So this demo session will happen now and tomorrow at 6 o'clock in the afternoon. So for today, we will have the demo session from the Blue Cloud Technical Framework, and it will be presented by Peter, Pasquale, and Massimiliano, and I'll give the floor to them. So thank you and enjoy. So I'm interrupting. So thank you so much. The floor is yours, Peter.
There we go. I guess you can see my screen now.
Yes, yes.
Perfect. So good afternoon. Good morning for some, maybe. My name is Peter Thijsse. I work for Maris, and we are as Maris, in person, my director, Dick Schaap, is technical coordinator of the Blue Cloud project. And the Blue Cloud project actually makes the first steps, or that's how we see it, the first steps towards a blue component for the EOSC, for EOSC. What I will do is I will focus on the data discovery and access service, and then this will be followed by presentation by Massimiliano and Pasquale about the virtual research environment. There we go. Yeah, now it's running. So the European data management landscape is very broad that we have as an if we look to the marine component, or if we want to form a blue cloud. We have many varieties, I hope you see my mouse, of ocean data flowing in, and of course it's very hard to connect to all these to build up a blue cloud. So what we do is we focus on what we call the data aggregators, which are providers of data products and services to aggregated collections of data. And they come from really a broad landscape of marine data, from historic data to more real-time, to Argo floaters that float in the oceans, to more biological biodiversity data, etc. So here you can see them again, the ones that are in focus. I will not all name them, but as I said, they range from remote sensing data to genes to biodiversity, water quality data, etc. That's on the left. We call them the blue data infrastructures. And on the right here, we have the e-infrastructures that we use as basis. Important components like G4Science, Blue Bridge Experience, EUDAT, and WECIO. They are the core components of the technical framework behind it. Here you get an impression of the variety of data that we have in CDataNet. It's a huge collection, more than 2.5 million data points from more than 100 connected national data centers. We have EMONET chemistry, which is really focusing, as it says, chemical side of data. We have Eurobis with biodiversity data, Argo with all these floaters, all these dots are floats in the ocean. And we have Wekio on the bottom right, which is remote sensing data. So it's a broad landscape of data that we have. And what we do in the Blue Cloud is we focus on 3 main components. The Blue Cloud Data Discovery and Access Service, a kind of federated service. I will focus on that a bit more. And then we have the 2 other main components are the Blue Cloud Virtual Research Environment and the Blue Cloud Virtual Labs. And these will be handled after my presentations. But the idea, of course, is that the Blue Cloud Data Discovery and Access Service allows users to dive into this wealth of data and bring that into that virtual research environment and into the labs. So how do we foresee that and how have we implemented it? So the concept is that we perform a federated discovery. So actually we work on metadata of all these data aggregators. And we follow a 2-step approach. The first step is you can use a few criteria to identify interesting collections and products from the Blue data infrastructures. And then if you find those, you can drill down a step further, where you can add more criteria to find specific data at the, what we call the granule level. So not a collection, but really at the individual data set level. And then, and in the end, you can add those to a shopping basket and actually, well, download them, or better, you can move them into the cloud for further processing in the VRE. How is this technically supported? On the first level, we have a metadata harvest. We're doing that via the GeoDAP metadata brokerage service developed by CNR. And this is fed into a repository where you can search then on the common fields. And then at that second level, where you do a search on granule level, we interact with the APIs and web services provided by the Blue data infrastructures. And then in the end, you add them to your shopping basket, your virtual shopping basket. So this is a bit of a complex diagram, if you see it first. But what you have to remember here is that we have various data aggregators, which actually all offer their aggregated metadata to the brokerage service, the GeoDAP that I mentioned, in which you can search. That's the level 1. And then actually in the level 2, we connect to the APIs of each of the data aggregators, where you really make the data order and retrieve the data and then store it and bring it into the VRE, the Blue Cloud VRE, where you can do further processing and work with the tools. And these APIs are by far not all identical, as you can see. And also the data, as well as the data, is not identical, but also there's a variety of services. So we make use of dedicated APIs, OGC, CSW services, even FTP, DCAT, and AirDAP services to retrieve the data. And instead of keeping it all really abstract, we have I have a short demonstration that you can get an impression of the interface. This is the let's say the landing page of the Blue Cloud Data Discovery and Access Service, and this is level 1. And what you can do here, well, let's make a very simple one. You can search for data from 2018 to 2020. I press search, and then you have to keep an eye on these numbers here, the level 1. You can see that depending on which data aggregator we're searching on, you can see that we have only 81 left that fulfill the requirements out of the 202 from EMONET chemistry. From EuroArgo, we have about 6,000 left, and what you can do, you can inspect them, and you can view the metadata, and you can see where it is. So this is what we call level 1. You can see the metadata, and you can find an interesting collection. What I can then do is I can say, bring me to level 2. And what I can see then, and I will press view maps, you can see for that, if I find that collection interesting, and this is from a certain float, I can see where it has been. I can zoom out a bit. It's a nice global data set. And I can see it on the map, and I can see the results, and I can inspect again. And this time I don't get it from the GeoDAP service, but I really get it from the API, what the data is, which parameter it holds. And I can just order the set. And now it's behind my, my camera icon. And you can see it here at the top right, that it's in your data basket. So to illustrate it a little bit more, let's go back. My by basket is still on the top right. It still continues. I can just start building up more data. I can also go directly into, for example, in this case, CDataNet. And then I can make this is the level 2 one. This offers me several facets that I can search on. And I can even go into who is actually the data supplier. I take the Marine Institute because I know they actually have quite a nice collection. And then I can again view the results, and I can say, well, these CTDs are actually what I need, and I want these, or I can, as I just did before, I can select the whole set. Or deselect. Well, what I do then in the end, I go to my data basket. I can see here what I ordered. I can submit it. I can give it an order name, test set. In this case, I confirm. Now my order is in, and now it will be picked up. And even if it comes from various data aggregators, it will be brought to me. And then I can view my standing orders. And now I can follow progress. This was one that I made this morning, and you can see that's now ready for download, and I can download it. The next one that we are working on, well, that is this function, and that is in progress, that we will push it into the VRE. So the user that is using the data discovery and access service can then bring that data into the VRE, and then Massimiliano and Pasquale will explain how that can be used further. So that is my presentation for now. If there are any questions for now, please. I think we have 1 minute or two. Paula?
Yes. You choose either now or at the end of the 3 presentations.
If there's an immediate question, I will stay until the end, so we can also do it at the end. Maybe it's better than that Pasquale continues with the full picture.
Yes, as Peter said, the discovery and access is the first step of the process. Then the user can store this data in the virtual research environment. So the virtual research environment is this environment that now you see on your screen. Is accessible at the bluecloud.d4science.org website. And when you arrive, in the VRE, the BlueCloud VRE, you have to register or to sign in. Clearly, for the registration process, you don't need to create a new account. You can log in with your academic or, your LinkedIn, Google, Twitter, or GitHub account. So you can use one of your already existing digital identity, and you can access. When you access the environment, you are presented with this interface where on the top you have a bar with the common facilities, including the workspace. And now I will go through very quickly on those facilities that are available for all members of the BlueCloud Gateway. Remember that BlueCloud is open access. And this means that you can access, the Blue Cloud gateway with your institutional account or with your Google account and so on, and you have access to this environment. This is my workspace. It's quite big, clearly, and since I collect a lot of data in this environment, I don't know if you can read, but I have, more than 200 gigabytes of data, stored, in this storage on the cloud. When you log in, you register, you have an account, you start with the 50 gigabytes of storage available to you. But according to your behavior, to the amount of resources that you share with your colleagues, this quota that is assigned to any user, is increased by the system. This looks like a normal, file system that you can browse and navigate online. You have, you can use the right click to see the contextual menu with all the functions that you may activate on the items, on the folder, on the files in the workspace. You can share with your colleagues, for example, getting, a shareable link to the resource. You can share a folder, or you can share a file, by just clicking and getting the link. Or you can look at the the metadata about the object. This is, for example, a presentation about the workspace itself, so you can easily navigate it and see the preview, or you can download each item that is stored in the workspace. Support versions. So in this case, for example, this presentation, there are 2 versions of it. So you can also get, the old version. You can generate a public link, share with your colleagues, even of a previous version of the object. And this is because any object get, a persistent identifier that you can use, to share your resources with others. There is an history of all the operations that are performed on the item. In this case, this is a private item, so I am the only one that I created. I read and I updated the object. But in case of a shared folder, you may see, the different interactions with the other users. So from the Discover and Access service, you will get your data directly in the workspace. And from the workspace, then you can use a number of, let me say, functions that you can activate from one of the virtual laboratories that we offer as a project. We may start from the Blue Cloud Lab. This is an environment where any user can perform analysis by using one of the technology that we offer, starting from the notebook through the Jupyter app that provide access to notebooks that are with the different server options. You may see that we also allow to create notebooks with 52 gigabytes of RAM and 8 cores, and this is quite let me say huge configuration that is not easy to find online. Clearly, when you start the notebook environment, a new instance of the Jupyter Lab is spawned on our infrastructure, and so you then you can access a standard Jupyter notebook. This is the last notebook that I use, that is to access the Wiki infrastructure data. But clearly, you can start a new notebook, and there you can start a notebook, with Python, with the Groovy, with Java, with the R, and so on, with Julia. 2 characteristics are Blue Cloud specific that are, from here you can access the workspace. So the same that I have shown before, with all your data, directly in the notebook environment. So if you have a folder shared with your colleagues, from here you can access and share with your colleagues, what you produce with the notebook and the notebook itself. And you have also access to what we call a data space. A data space is a 1 terabyte volume that is accessible to all users, in any virtual laboratory. So the virtual laboratory has this environment, this volume that you can use to share your data with the other members of the virtual laboratory. In this case, we start from an allocation of 1 terabyte to each community. But the notebook environment is not the only environment that we offer. If you are used to use RStudio, R language, you may start, an RStudio instance. In this case, an RStudio server is allocated to you and is, loaded in. For you, this is my last session where I was analyzing, a time series, and clearly, and also from here you can access again, the workspace, and with all the data that you have in your workspace, and again from RStudio as well, you can share data with your colleagues. And coming back instead, I can also perform, use an analytical engine, executing one or more experiment, by using, methods, algorithms that I have integrated, or, by re-executing an experiment that I performed, in the past. This is the long list of data analysis that I performed. And for each of these, I can see all the metadata, all the provenance information. So clearly the output, but also the input parameter that I used when I executed this analysis and so on. And from this list of computation, I can resubmit the same job. And this is, true for all jobs, even if I go very, very far in the past, this is, for example, 2020. And again, I can see the metadata, and I can see all the parameters of the execution. I can download the output, or I can resubmit the same job, or I can share with my colleagues. So this is the Blue Cloud Lab environment, but we have the different demonstrators that are developing different services, and all of those access to the same platform. So if I go to, for example, to the Marine Environmental Indicator, here I have the Marine Environmental Indicator generator, where I can easily generate, for example, a climatologic map of the salinity for this year, and then I can execute the process. Now the process is under execution, and again, I can go or here in my data, or directly in the analytics engine, check the computation and see that the new job is ongoing, is running, is not yet completed. And as soon as it complete, it will become available from here, and I can download the data or share with other colleagues. And all the results of my computation are automatically stored in the workspace in such a way that I can re-access, reshare, and with other colleagues. So there are different demonstrators. Each of these demonstrators has a description and a function. There is no time in this demo to show all the environments, but you are free to access. They are open access, and so you can navigate, explore the resources, and also invite your colleague and share the data or the processes that you may want to integrate in this environment, and use the Blue Cloud facilities as you need. Just the last information, and then I give the floor to you. For example, if you go to the Fishery Atlas, that is another demonstrator, you can navigate a catalog of products in this case. And again, this is a catalog of products collected by the colleagues in Blue Cloud. You can navigate and see on the map, all the products. So, yeah. So this is about Blue Cloud. I don't know. I have not seen if you have put questions in the chat, but
Yes,
you know,
there is at least 2 questions. One from Carolina Minch. Hello, what is the plan to maintain this project? Like any sustainability development plan for service, etc. And another one from myzam.com. Does the user able to have access to data through the Blue Cloud dashboard, which are larger than the available space to the user? For example, data in order of TB. I don't know what.
Yeah, terabyte.
Okay.
I can take, you know, the 2 questions if you agree. And, you know, to Carolina, let me say that Blue Cloud is a project that is, you know, as you have seen in the presentation from Peter, is powered by D4Science. D4Science is an infrastructure not, you know, related, is a long-term initiative by the National Research Council in Italy. So, and we plan to maintain the Blue Cloud services for at least, you know, 2 years after the end of the project. However, according to our experience also that we did in other projects with the D4Science, you know, many of those services are maintained by D4Science even after these 2 additional years, in agreement with the communities, in this case with the Blue Cloud communities. Okay, so, and to Mesam instead, you know, there is a space that is the private space of each user is limited to 50 gigabytes per user. However, you know, the virtual research environment and the virtual laboratories have, you know, additional volumes. As I said, you know, for the notebooks, we currently create, you know, the data space that is 1 terabyte. So, and this is the default that we are you know, providing to our user, provisioning to our user. For each virtual laboratory in the workspace, there is an area that we call VRE folder. This is different from the private area of the user and is currently unlimited. So we have not put any quota on the space that can be, for example, stored in one of these demonstrators, like the marine environmental indicators or the plankton genomics and so on. Clearly, you know, large volume of data, you know, I mean, we support requests and we interact with our communities. So for larger for requests of large volumes, you know, it's better to synchronize, you know, to open a support request in such a way that we can assign the proper resources.
So we have one more question here from Chris.
The sharing service of the data with the scientists is done via D4Science or UDAT. So let me say that the 2 platforms are integrated. I mean, we are not, I mean, D4Science is part of, is federated with EOSC and also is federated with the UDAT services. So the data, the persistent storage of the data is performed via D4Science, in the sense that from the data discovery and access service through the basket mechanism, the data are temporarily stored, you know, in a volume, and then, you know, moved to D4Science upon request of the user. So the user, if needed, and if the user want to share this collection of data sets or, you know, the processes about those data sets with other users, you know, may move this data to the D4Science persistence, so to the D4Science storage, in such a way to enable all the, you know, services that I have shown you, including, you know, the provenance. Because, for example, I have shown very quickly, you know, the capability to repeat an experiment. And this is possible clearly, you know, the repeat or share, you know, an execution of an, you know, of an experiment only if, you know, we maintain all the data and we assign to them a unique identifier and so on. And for this, we need to move the data to the Forsense storage. I hope that I was clear and I,
Yes.
clarified all the doubts.
We don't have more questions, and we're coming to the end of our session. I don't know if anyone would like to pose another question or address a comment to the speakers. So thank you in advance, Pasquale, Peter, Massimiliano, for your demo presentation about Blue Cloud Technical Framework. I inform that this demo will be repeated tomorrow at 6 p.m. So we expect that every one of you can join the session tomorrow. And for now, if you don't have anything more to say, I think I will close the session and have a good lunch.
Thank you.
Thank you.
Thank you.
For
Bye-bye.
Bye-bye.
Bye.
Bye-bye.
Goodbye.